Sorry about the wind noise. I need a windmill. It's a very gloomy day. I think maybe the sun's somewhere over there somewhere. But there's all 12.2 kilowatts. I got 6 kilowatts on the roof, and I got 6.2 down here in the ground mount. Now I'm in no way, shape, or form done with this system. Just a lot of loose ends and stuff I gotta tie together, such as the ground wire. I gotta get that buried, but that goes from this array and that array. In reality, each panel should have its own ground bar, but over here I got the Midnight Solar combiner disconnect, the surge suppressor, and over here I've got another Midnight Solar combiner box. Just doesn't have the external disconnect for whatever reason. I was looking for that one when I bought this one, but I couldn't find it. And then later, when I was putting in the second string, I found it. So I'll probably end up buying another one, putting it here, and taking this one and putting it in the basement, so I have a local disconnect for when I want to mess with it or service something down there. I can just shut it off from inside the house. So from there, basically using this as a lean-to, put some stuff under it. That's got to get put inside before the real snow hits. But I really didn't want to poke any holes in my roof as far as get the conduit up there, and I thought that 1.5 seal tight worked pretty well. And then all that runs in a trench right here. Here's new drain tiles I put in this summer too. But you can see that trench where it went off that way. Of course, you got the backup generator, and that's got a 50 amp twist lock plug that I can plug into my house over here. All the spare wire and leftovers. Garden hose. I was just washing off the panels. I left the garden hose out there. So there's the twist lock entrance for the generator. Let's go in the house. It is windy. I need a windmill. There it is. Obviously, you got a workbench and all your crap. I got some stuff on the floor down here that still needs to be put away, but in general, the area is accessible and clean. So that's where it enters the side of the house. There's 2 strings. There's number 2 aluminum, direct bury outside from the panels at this point. And here it transitions to copper. Now it's number 4 copper. So there's 4 runs here, 2 positives, 2 negatives. That runs over to here, where it doubles around. Turn flash on. That big service loop, this cabinet's on wheels, where then it enters. Get that open. It enters at the bottom of the cabinet here. I got some exits there too. So that's the THHN. Doesn't have to be in conduit when it's inside of an electrical cabinet. It's in conduit everywhere else. So the power comes from there. It pops out right here. I've got a ton of these things. These ferrite chokes. I don't know if they're actually going to do anything. I need to get bigger ones that will actually clamp over the whole thing and go from there. Basically, and it comes into the MPP solar. Focus. Like I said, it's a really, really poor solar day. So I got 12.2 kilowatts out there. I got 1.2 on panel 1 and 1.15 on the other panel. So the panel set on the roof is used, and the other panel is brand new. The used panels cost me $2,000. The new panels cost me $5,600. So I mean, if you can find a set of panels that, like, just say they have like frame separation and no delamination or anything like that, but just frame separation, I'd jump on them, because I think I got these from Santan Solar, and it was a screaming good deal. None of them showed up broken. The new panels, you know, I paid twice as much for them, and one of them showed up broken, so I ended up with one less than I wanted to. Now I got one spare because I had to run them in parallel in Series 2. So yeah, 1.15, 1.2. I do have an AC input from the grid. So right now, we're not pulling anything from the batteries, and we're putting in 15 or 16 amps. Depends on as the clouds split. Batteries are pretty depleted right now. We're not running much load. Kids upstairs watching TV. I hear at least one furnace on behind me. I have two furnaces. We've got this Watchman. That doesn't work at all. It won't even sync to the Wi-Fi. I heard everybody complain about it, and I still bought one like a fool. I'm gonna get Solar Assistant. So then we got this guy. This is a burner phone. I got another one upstairs. There's nothing on it except for this, these two softwares. I think the Victron software is pretty good, trustworthy, but the Zhaozheng, I wouldn't put it on anything you care about. I'm just saying that. Don't sue me. Personal feelings about Chinese software. So right now we're only at 27%, and it's at 50.3 volts. Fully charged is 57. So the batteries are pretty low. It's been really bad overcast like the last week. But we are currently charging the batteries with 750, 780 watts. But then we're also using 1,000 watts in the house too. So that's where all the power is going there. Time remaining, it doesn't even give one, because this is a 50 kilowatt hour battery that's currently connected. And I have another 20 down there. So it'll be these three. Will be another 20, and I'll have one spare, because I have to use one 10S brick and then cut a 10S brick in half and make a 4S brick, so I have 14S. So I'm going to end up having two spares on that one. So in reality, I'll be too short, which I have other lithium batteries. Maybe I can, just depends on how much I want to Frankenstein that to make another 9 kilowatt hours, I think, or something like that. It'd be about another 10 kilowatt hours. So all of these, it's on a steel shelf, pallet racking. I've got this cover off here. It's right behind me, just because I want to show you guys in there. It's pallet racking. Got all my tools up there, need to be cleaned off. And it is all covered in cement board, 1/2-inch cement board. The ceiling's been covered in cement board. I'm going to take that cement board further out to about here, and I'm going to put the face on it, all cement board. But while I was initially getting it up and running, I wanted to check it with the FLIR thermal imaging, and nothing gets warm at all. There's so many batteries that it never pulls or pushes on anything hard enough. These are 100 amp BMSs from Jaibaida, JBDs basically, and these don't ever get warm. And then this is all number 4 welding wire. It's all copper, pure copper, not copper clad. And I've got an 80 amp breaker. It's got 10,000 amp surge. Where is it? Right there. Nope. 6,000 amp arc fault breaking capacity. So these are all on breakers and BMSs. And then that goes to a bus bar here, which combines all these together. And from here it goes to, and this is all American made wire too. Even this 4-gauge stuff, it's all from the same people. Made in USA. This is 4-aught. EWCS is the brand, and it's good stuff. So all those number 4s come to here and then take it to a 4-aught. Now this is SO cord, so it's allowed to be outside without being in conduit. It's only 60 volts. So from there it passes inside the cabinet and goes to another bus bar. So now, if you want to argue that the wires are longer on these batteries than they are going from this bus bar to these batteries, I would agree with you. Between the internal resistance being slightly different, because these are prismatics and these are pouch, they definitely don't all charge evenly, but they're all at the same voltage. You know, so you'll typically see these charge like not as hard. These will charge a little harder, and then these will catch up. And then when they're discharging, same thing, these will discharge faster. These will catch up, but all the voltage maintains the same. But it's definitely just, you know, you can tell these are primary. When you're talking about 0.1 volt difference, it's enough to where it pulls on those first. Will that be a problem in 10 years over time? Maybe. I don't know. There's some other cells. I've got, I think, 8 more outside that I could use to make that a whole pack, but I just don't know if I'm going to need to. Probably will. There's the other bus bar that these 3 strings go to. String 1, string 2, string 3. Same thing. These things have BMSs and breakers. And then this. So then from here, it goes through a Victron Smart Shunt that I have hooked right up to the bus bar. Just Bluetooth to this phone here. So there's our main negative. Now this is 2-aught. It's good for 150 amps at this length, but it's going to be upsized. And then this is our main positive. Both of those kind of loop down and then come up in here, and they go to the top of the breaker on the other side, and then they come out of the breaker at the bottom here, and that's where they pop out here and go into the inverter. And like I said, these are 2-aught. Right there, 2-aught. So it's on a 150 amp breaker, but I am definitely going to get rid of, well, I'm not going to get rid of it. I'm going to replace this with a Growatt 12 kW. This just doesn't really have any surge at all. It seems like this one will, what were we doing? We were slicing bacon, and just every time the meat slicer came on, you'd see the flicker, and it would kick over the grid. Once it was going for 15 minutes and we were cutting, then, you know, it was fine. It would switch back. But it won't even start a meat slicer, you know? So what happens if there's no grid and we're off generator? It's going to constantly trip. Plus, these things, these high-frequency inverters, absolutely are prone to light flicker. The lights just flicker when the load is constantly changed, whether it's extra load or less load, or I think it's mostly when the load drops. When all of a sudden it goes from a heavy load to no load, the lights flicker. I've noticed that. And I don't believe the low frequency inverters suffer from the same issues. There's the battery switch. Just like got it closed. Okay, so now, what do we got? So we're going to do the complete walkthrough, even though I've done a video on this before. So basically, we've got our grid power. Turn off the light. We got our grid power. This is going to my meter. This is the panel we don't like to use. I think I've got plans for that guy, so they'll yell at me for it being open at the moment. But this is a 200 amp pass-through panel. So it goes up to the meter base, outside. Turn the light back on. And then, I don't know why it's focusing so much. Inverter outlet. Air conditioning 1, air conditioning 2. I got 2 furnaces, 2 air conditioning units. Just the way this house was done. It's a 2-story house. It's an older house, so they just put a second unit in the attic. It was just easier than getting ductwork up there. That, and it's nice for it's nice for zone control, I think. Okay, so that one outlet that said for the inverter outlet, that's these guys down here. That's one of them. So these inverters have a bypass function, which we've been using a lot in the last week because it's been so cloudy out. Where if the battery gets too low, or like I said, if it's overloaded, it will pull from the grid. So this plug, the 50 amp like camper plug, that is coming from bypass from grid power. It's a plug. So that powers the inverter on one of these two. I don't remember which one it was. And then so one's power in from the grid and one's power out to the critical loads. Then this one is if we want to use the generator to power the house and charge the batteries. Let's say the grid is down, right? Or all of a sudden electricity costs more than diesel fuel, which who knows. I can unplug this from here, plug it into the generator plug. Right now I have this programmed to only charge batteries from solar. But if I want to change it, instructions are in there, but I just wrote them on the front page. Hold enter till beep. The fall light's not on, just the lights make it look lit up. Go to 16, change to SNU from 050. And that's it. And then it will now start charging the batteries from the grid along with solar charging. So if the grid is down, and like right now we have very little sun, barely enough to charge the batteries, just enough to run the house during the daytime, then we could plug and plug here, plug in there, go start the generator outside, hook it up to the outlet outside like I showed you, which is basically the same as this one here, and then run the generator, which would power the inverter, charge the batteries, and then also power the house all at the same time. So this way we're really getting the most efficient use out of that generator. It's a 12 kilowatt diesel military unit. It's a MEP 803A, and it's got 300% surge rating. It'll start 2 5-ton air conditioners at the same time. It's a bad unit, but whether you're 50% loaded or less, it's going to use the same amount of fuel. So you might as well get it up at least to 50%. And running this house at 1,500, 2,000 watts, or when you're cooking more like that, it's the only time the thing's barely loaded. So you might as well add. I think this will only charge 60 amps from grid. 60 amps to the battery at 48 volts. I think it's only like 3,500 watts that'll pull from the grid. So the generator pull 3,500 watts plus the loads. So it's got plenty of room to be able to charge the batteries, which I think it will take 10 hours or something to charge the batteries. Now that it's 50 kilowatts, but soon to be 70 kilowatts. The only reason why it's not 70 yet is because I need 2 more battery BMSs, battery management systems. Still waiting on them to come from China. Okay, so We've got these two outlets here that supply power to the inverter and the house, right? So I can either choose grid or generator. Now the power is coming from the inverter to this outlet. From that outlet, it's going over to this sub panel here. Which I have labeled, and I'm hoping it's idiot proof in case for some reason I'm not here. It should be easy enough to understand. So there's my two outlets. Well, there's one outlet, and then the other one's a receptacle. Solar bypass interlock from generator sub panel from solar plug to critical loads panel. So it's an interlock. This breaker is getting power from the generator sub panel. This breaker is getting power from the outlet. So right now the power is coming from the inverter into the outlet, into this breaker, from this breaker, and it's going back into, maybe I should have showed this one first. My critical loads panel. So now, because this is a pass-through panel, it's got lugs on the bottom of it. And those lugs are then wired through this. It's not focusing. Through this into the top grid main 200 amp breaker, right? So I can't turn on the main breaker. Interlocked. Right now I'm having auxiliary power powering my whole house. The electric stove, the double electric ovens, surge protector, gotta have another surge protector. Some pumps, dehumidifiers, and all the outlets need to be labeled. Then there's two furnaces. Right, so I can pick whether I want to run the house from grid power, right, which is just everything is normal like everybody else runs it, or auxiliary power, right? It should always basically be an auxiliary power, because if the batteries are dead, it's bypassing through these plugs anyways, automatically. So this is really just like mechanical bypasses and interlocks in case for some reason my generators are broke and my inverters are broken, all my off-grid stuff is broken. I can bypass all of that by just putting the grid back on, which hopefully never happens, but it's there because that's the way it should be. Should always have options. Engineer 775, he is a man of transfer switches and options, and I have to agree with him. I don't care if there's an automatic transfer switch in the inverter, you should always have a mechanical one in case the inverter or something happens and you got to take it down. You don't want to be left without power. Okay. Solar bypass interlock. So basically you're only ever going to use this if solar is broken, because when you do this, it's now taking power directly from the generator and right into the critical loads panel. You should never need to do that. I would rather switch those plugs around than flick this, because then I can charge the batteries at the same time. So basically this should never get touched. Neither one of these panels should really ever be touched. But you should only use this if, for some reason, the inverter is broke, right? If the inverter went down, that'd be the only reason for it. So other than that, shouldn't have to do anything with it. And then this one's always on. So this is the outlet outside that I showed you. It's feeding the main lugs in here. And from there, it's to the generator plug down there. and 2 the bypass, which is the panel right next to it, solar bypass. So you should always have these on. There should really be no reason, like right now they're not energized, but they should still be on. So that, in a nutshell, is everything that we got going on in here. I'm hoping I'm going to make a printout that says exactly how to switch everything over in case of something happens. Make it like an aviation manual and go from there. That's a nice power supply. Goes to 55 volts at 55 amps. It's an antique, but it works great. Really happy with these batteries here. Can't wait till I get the other 2 set up and running. Go from 50 to 70 kilowatts. Kilowatt hours. This is somewhere, I know it. Ah, 5.94 kilowatt hours. And then this is 2.35 something kilowatt hours. It's just shy of 10 kilowatt hours. Let's see, we're just getting about 756 watts now. Man, glare. Almost identical between brand new panels and used panels. I'd say go with the used, guys. I don't really see it. As long as it doesn't say anything about delamination or shadowing or spidering on the glass. These were pretty good panels. Because I bought Helena's, which are American made, 390 watt panels. And the Turkish brand that I bought used are 370 watt panels, and they put out the exact same power. Which I'm happy and sad, because I could have just bought an all used panel to begin with and saved myself several thousands of dollars. Yeah, having to cut these in half is way easier than bolting them all together like David Paz did. He got raw cells. You don't want to play, do you? Cool story. There you go. So basically, when they get them, they're cut way down there, right at the base of this pinch weld that they got going on here. So you lose with this whole tab. Well, all I had to do was I drilled out these little rivets. I just broke them off. They're plastic. And then I took a set of tin snips and very carefully just cut right down this. And then I ended up with a stout. I mean, these are probably almost a millimeter thick. Just bolted right to it. Just copper crimp connections. Definitely, I recommend using hydraulic crimpers. I had to buy 2 because wasn't paying attention. These are the ones you get from Harbor Freight. They come with a bunch of dies, but I think the biggest die is like 2 gauge. I don't think it gets bigger than that. Like, there's dies in here for 12 and 14 gauge. what do you need a hydraulic crimper for doing 12 and 14 gauge wires for? So as far as buying this, I recommend not. And I bought one, and the first one didn't even work. Like, it worked for a while. I made like 3 crimps, and then the internal seals failed. It was like you left this open the whole time. No matter how tight you got that, it just would not crimp. The one I ended up getting and replacing, it was over here too. Let me take a look. Anyway, I'm not really sure where my other crimper went, but it was the one on Amazon that's got the pull pin on the end. And I recommend that more than anything else. But that's the system in a nutshell. Because when you're doing 4/0 crimps like that, you really need a big hydraulic crimper. That's it.